Hi everyone, welcome back to my Epidemiology Research Methods project. My name is Emily. Today we will be going over cohort studies. This is Module 2, so let's go ahead and get started. So cohort studies begin with an exposure. Basically, an epidemiologist identifies an exposure that they think may lead to some sort of outcome. So they decide to study it and they create their hypothesis around that exposure. In a cohort study, 4 groups are identified. The first group is those exposed who do experience a specific outcome. Those exposed who do not experience the outcome in question, those who are not exposed but who do still experience the outcome in question, and finally, those who are not exposed who do not experience the outcome in question. Cohort studies are observational studies, and as we mentioned in Module 1, this means that the investigator does not select which subjects are exposed and which subjects are not exposed. They simply observe from the outside without any intervention to the subjects. So cohort studies are most useful when the investigator can already identify that an exposure may be linked to an outcome, meaning they already sort of have an idea that the exposure they want to study may lead to something. Since the exposure is the starting point, it's only worth studying if the investigator thinks that something is going to happen because of the exposure. And cohort studies are also useful when an exposure is rare because you collect your subjects based on exposures. And the study would either support or disprove a correlation between exposure and outcome, provided that the investigator's data is statistically significant. In Module 1, we talked about prospective versus retrospective studies, and cohort studies can be either prospective or retrospective. So in a prospective study, the investigator observes exposures and outcomes as they happen in real time. So if here is now, and here is the exposure, then we observe for an outcome in real time. Okay, so an example would be a study of recent female college graduates in Sacramento. The exposure in question would be a desk job. Some college graduates take desk jobs while others will go on to take more physical jobs. And the outcome in question is weight gain. So the investigator will wait as these college graduates leave school, enter the workforce, and either gain or do not gain weight over time. A retrospective cohort study, on the other hand, means that the exposures and outcomes have already occurred. So here is now, way back here is the exposure, and here is the outcome. We look back in the past for that data. So the investigator uses, in general, pre-existing data such as hospital, school, or public records. For example, a retrospective cohort study would be a study of women who smoked during pregnancy in the 1960s. The exposure would be maternal smoking while pregnant, and the outcome would be low birth weight. This is a retrospective cohort study because all events in the study have already happened at the start of the study, and we're looking in the past to get the data. Cohorts should be carefully selected. as the results of a study can change drastically based on how cohorts were identified. So if cohorts are chosen poorly, then the quality of an investigator's data can really suffer. And what I mean by if cohorts are chosen poorly, I mean if a cohort is not generalizable to the general public. So if a cohort is not representative of the general public, or for instance, if a cohort may have some sort of comorbidity that could confound the association between exposure and outcome. So those are all things that an investigator would need to pay attention to. The investigator also needs to decide how long cohorts should be followed and what the parameters for cohorts are. So the parameters would be our inclusion and exclusion criteria for subjects. So what geographic location they should come from, what age they are, what race, what sex. The investigator basically decides what group of people they want to study. The measure of association that we use in cohort studies is relative risk. So relative risk is the cumulative incidence in the exposed group divided by the cumulative incidence in the unexposed group. Risk ratios can also be calculated using incidence density, but in the following example, I'm going to use cumulative incidence. So we use risk ratios to determine what the correlation between exposure and outcome is. So we will call the group that is exposed and develops an outcome group A, and the group that is exposed but does not develop an outcome group B. The cumulative incidence in the exposed group would be A over A plus B, and for the sake of simplicity, we'll call that X. So cumulative incidence in the exposed group is called X. Now we calculate cumulative incidence in the unexposed group. So group C would be those who are unexposed and develop the outcome anyway. Group D would be those who are unexposed and do not develop an outcome. Cumulative incidence in the unexposed group would be C over C plus D. So those who develop an outcome out of the entire unexposed population. And for simplicity's sake, we'll call this Y. Relative risk ratio would be cumulative incidence in the exposed over unexposed, or X over Y, and we'll call it Z. So if Z equals 1 or is greater than 1 or is less than 1, what do you think that means? Go ahead and pause the video to think about that for a second. If Z equals 1, there does not appear to be a correlation between exposure and outcome. We call that the null hypothesis. If Z is greater than 1, there does appear to be a correlation between exposure and outcome. And if Z is less than 1, the exposure appears to have a protective effect against the outcome. A common example of this would be vaccines. For instance, the exposure could be a vaccine, and the vaccine could have a protective effect against the outcome that the vaccine is trying to prevent. Let's talk about sources of bias. Loss to follow-up can be a major problem in prospective cohort studies. Because subjects are followed over such a long period of time, there is a lot of time for subjects to become unreachable and therefore unable to contribute any more data. Self-selection bias is closely related to loss to follow-up. Self-selection bias means that subjects self-select into a group that can cause some sort of bias within the study. So the question to ask here would be, is there something that the loss to follow-up patients have in common that may be related to the outcome? So, for example, if the patients who are becoming lost to follow-up are much sicker than patients who are staying in the study, then that would create bias. Another source of bias would be incompleteness of available data. This is more of a problem in retrospective cohort studies. The investigator is relying on data that already exists, so this data could be limited or incomplete. Additionally, those who develop an outcome may be followed more closely by doctors and therefore have more data to provide. This is problematic because it causes bias. Let's practice with an example. So in 2005, 204 elementary school teachers in Southern California are asked about their Diet Coke consumption. They are followed for Diet Coke consumption and gastric cancer diagnosis until 2015. None of the teachers had gastric cancer at the beginning of the study. So let's make our 2x2 table here. This is a standard 2x2 table, so we have the exposure on the y-axis and the outcome on the x-axis. So here we have group A, those who are exposed who develop the outcome, and down here we have group D, those who are not exposed and who do not develop the outcome, and then groups B and C fit in here. Let's calculate the cumulative incidence in the exposed group. So as we mentioned earlier, the cumulative incidence is A over A plus B. So let's look at those numbers. So we would have 65 over 65 plus 48. Next, we need to calculate the CI in the unexposed group. So that would be C over C plus D, or those who are not exposed and who develop the outcome. So we'll call them the unexposed cases divided by the entire unexposed population. Let's go back to look at those numbers one more time. So here we would have 33 over 33 plus 58. Then to calculate our relative risk ratio, we need to divide the CI in the exposed group divided by the CI in the unexposed group. So once we put all of those calculations together, we get a relative risk ratio of 1.586. What does this mean? Go ahead and pause while you think about this for a minute. So this means that individuals who drink Diet Coke are 1.586 times more likely to develop gastric cancer compared to individuals who do not drink Diet Coke in this elementary school in Southern California. It's always important to relate your interpretations back to your study population. Let's take a quick quiz. First, is this study prospective or retrospective? This is a prospective study. And for what kind of bias might this study be at risk? This would be a study that is at risk for loss to follow-up because it is a prospective study. So, today we went over cohort studies. Next time in Module 3, we will go over case control studies. Thanks so much for watching, and I'll speak with you next time.